Well, another article that I really enjoyed is this common sense knowledge based completion with structural and semantic context. You know that these common sense knowledge bases like ConceptNet and Atomic, they're very sparse. So that's why the completion is much more difficult than very simple knowledge bases like the ones that we use for semantic parsing. So I want to explain this article in 2020 by Allen Institute of Artificial Intelligence and University of Washington. And there are very beautiful papers that use path-based reasoning. So, the path in your knowledge graph, the path that you go from one node, from one concept to the other one. And so ConceptNet and Atomic are more sparse than Freebase. Freebase, as I said, is very simple. But ConceptNet and Atomic, first of all, they are huge. Second of all, they are very sparse. And so it's challenging. So this is an example of subgraph from ConceptNet that illustrating semantic diversity of nodes. So these dashed blue lines are the potential edges. It may not be even exist. And if it exists, we should know the relation between them. It is important to note that, for example, go to dentist, this is like a sentence that in each node you have a sentence. So it's a little bit different from Freebase or other knowledge bases that is just a word or single token. So we investigate two key ideas for performing completion of common sense knowledge. So we want to complete to see if two nodes are related to each other or not. We want to transfer learning from language to knowledge graphs. So here we use fine-tuned BERT lookup table. We take advantage of BERT as well. And secondly, we want to learn from graph structure. So how can we combine them? So this is the architecture. First, there is an encoder, and it gives us synthetic links. And then we give it to graph convolutional networks that I've explained on my playlist for GNN. And here we also use the BERT because it has a good, for example, brush your teeth can be encoded using BERT very easily. So we combine these two to have a better representation. So not only each node we give it to the graph neural networks, graph convolutional networks, but also we give it to the BERT. And for the decoder, we use these convolutional filters and we have the probability for each of them. So given a knowledge graph where N is the set of nodes and V is set of edges, we want to see what is your entity. So from one entity and relation, we want to predict the second entity, because we go from one entity to another entity via a relation. So given that we have these, how can we predict the second entity? And because we need these probabilities. And the objective of knowledge-based completion task is to maximize the score of a target entity. This is our target entity, given your E1 and relation, as I said. So we want to maximize the score of this final entity. So we use transfer learning from text to knowledge graph, as I said, and also we use the graph convolutional neural networks, and it was invented in 2017 in University of Netherlands, University of Amsterdam, and so we transfer learning from text to knowledge graph. These are hidden representation. So beta comes here, and you know that beta is the vector is the relative importance of each node, of each entity of each entity's neighbors. And we should do graph densification, because the sparsity of common sense knowledge graphs makes it challenging for graph convolutional networks to perform information propagation over a node's neighborhood. And we use the convolutional decoder. So the score of a tuple, as I said, can be computed like this. So the output of the kernel C is M of C, and the concatenated output for all kernels is M. So as the graph size increases, it becomes computationally intensive to train with the entire graph in memory. If you download the concept net, you see it's very huge. That's why they provide an API for that. They say you don't need to download everything. You can just use the API. But I prefer to download it because it's faster, although it's very big. Although you don't need 30 gigabyte of memory, although it is recommended. I have just 16 gigabyte of memory. It works fine. It works perfect. In my Asus, my Asus has just one simple GeForce GPU, and it's perfect. Everything is perfect. Although you don't need GPU, you just need 16 gigabytes of RAM. But if you don't have these expensive things, you can use API directly, and having a good internet speed, you can take advantage of that. And we show that existing knowledge base completion models underperform with common sense knowledge graphs due to the sparsity and scale of these graphs. So we proposed novel knowledge-based completion models which are enriched by structural and semantic context obtained from graph convolutional networks and language model representations.